All right, this is the Chapter 6 review, Part 1. So we're just dealing with a lot of the basics here in Part 1. Part 2, we'll crank it up a little bit and do some application problems. So this is just a lot of like operations and things like that. So number one, I noticed this is addition. So when you're adding two polynomials, you're just gathering up like terms. So I'm going to put the b to the thirds together. So 15b to the third. Looks like we have negative 7b, positive 8b. So that's a positive 1b. And then finally our constants. We have a positive 5, a negative 1. So that looks like it'll be plus 4. Typically we put them in order of descending powers, but it's not super critical. All right, number 2, the thing you have to be careful on with number 2, and they really like this one on the SAT, is subtracting polynomials is a little bit trickier. So when you subtract polynomials, the big thing is distribute this negative 1 through the parentheses. You know, the first parentheses is just a positive one, so you can just drop the parentheses for the first part. But the second part, that negative 1 basically changes everybody's sign. It makes everybody opposite of what they originally were. So I've made everybody in the second parenthesis opposite. Now I do just like in number 1. Gather up my like terms. That gives me a negative n to the fourth. The next biggest power there would be the n's. So I have 7n, negative 2n. That's a plus 5n. And then lastly, my constants, positive 7, positive 4 is a positive 11. All right, moving on down to number 3. Number 3, there is no sign in between the two parentheses. So this one is going to be multiplication. So basically I'm going to be double distributing. So I'm going to do this 2x basically times all three pieces. And then I'm going to come down here and I'm going to do the negative 4y times all three pieces. So I'm going to have 6 terms. And then I'm going to have to kind of put those together. And sometimes I do this as I go. So I'll kind of show you. So the blue stuff, I'm going to get, that would be 14x to the third. And then 2x times 7xy, that's 14x squared y. And then the 2x times the negative 6y squared is negative 12xy squared. So right now there's no like terms there. There's no way that has the exact same combination of powers. So let's move into the reds. Well, in the reds I have negative 28x squared y. Negative 28x squared y. So I'm going to stack those underneath the people they go with. Then I'm going to have a negative 28xy squared, which goes right here. And then the last arrow is a positive 24y to the third. So that's going to kind of bring up the caboose. So when I put all this together, I have 14x to the third. Looks like minus 14x squared y. Then we have a negative 40xy to the third. And then a positive 24y to the third power, bringing up the rear. There we go. So that's multiplying a 2 by 3. So then we go up to the top. Now we have a 3 by 3. I'm going to show you a different way. Instead of using the arrows, I'm going to do boxes. So I'm going to do a 3 by 3, showing you the box method. Kind of similar to lattice, if you did that back in the day when you were younger. So the first expression can go either on the top or the side, doesn't really matter. I'll put it down the side. Make sure you include the signs with them. Then across the top, 5r squared, positive 2r, negative 4. And then what goes inside, you multiply each row by column. So this would be a negative 20r to the fourth. This would be a negative 8r to the third. Positive 16r squared. Next row, I get 35r to the third. 14r squared. And negative 28r. And then I have 10r squared, and 4r, and negative 8. Now usually, not always, but usually you can gather up like terms on the diagonals. So for instance, he's the only r to the fourth, so it's going to be a negative 20 r to the fourth. These two can then go together. It's 35 and negative 8, that's 27. I think my battery's running out of juice here. Finish up this problem and then I'll try to track down a new one. So that's 30, that'd be 40 r squareds. Right here, the r's, that's a negative 24 r. And then the minus 8 is, if I can finish here, is right there at the end. All right, number 5, we're going to expand using Pascal's triangle. So quick refresher, Pascal's triangle, basically you start with a 1, 1, 1, then you add in between the two numbers. And we've done this back in the video notes earlier, so I'm not going to kind of repeat that whole process. But basically when you want to expand, since this is the fourth power, I'm going to go to the fourth row. And these are going to be my coefficients here in the front. So I know I'm going to have a 1, a 4, a 6, a 4, and a 1. And then how the game is played is you take the first piece of the expression and you start it to the fourth power, then you decrease it by 1 every single time. x2, x1, and then there'll be none of them in the last piece. Then you take the next expression at negative 2y, and there's none in the first one, and then you start building that one up. So you go negative 2y to the first, negative 2y squared, negative 2y to the third, and negative 2y to the fourth. And now we got to kind of clean all this stuff up. So in the beginning, I'm going to have x to the fourth. Negative 2y to the first is just negative 2y, so that's going to be a minus 8x to the third y. Now I got to be a little bit careful here. So this one I have a 6 times x squared. A negative 2 times itself is 4, and then y times itself is y squared. So putting all that together, I have a 24x squared y squared. On the next one, I'm going to have a 4 times an x. Negative 2 to the third power is a negative 8. And then y to the third power is just y to the third. So that all becomes negative 32xy to the third. And then negative 2y times itself 4 times. Negative 2 to the fourth power is 16. And that would be y to the fourth. So there's that expression expanded out without having to multiply it 4 separate times. All right, moving right along. Number 6, we have a division problem here. Number 6, this is a long division problem. You could use synthetic division, but basically whenever I see a coefficient here, I do long division. So I'm going to set it up that way. 3n plus 5. And I'm going to put 9n to the third plus 12n squared minus 11n minus 3. So 3n goes into 9n to the third, 3n squared times. Then I multiply backwards. So I kind of come back this way. And I have 9n to the third plus 15n squared. I'm going to subtract that, and I get negative 3n squared minus 11n. And then I have to say, well, just how many times does 3n go into negative 3n squared? And that's going to be a negative n, let me see. Subtract, came down. Oh, 3n goes into negative 3n squared n times. That's a minus n. And I would get negative 3n squared minus 5n. Then I have to subtract that. So this goes away. Now I have plus a positive. So that's a negative 6n. Bring down my negative 3. And 3n goes into negative 6n, negative 2 times. And that's going to be negative 6n minus 10. And so that's going to go away, plus a positive. I have a 7. So what I'm going to do is I'm going to put that positive and I put 7 on top of this piece that we were dividing by. So my final answer is all of this stuff up on top here. All right, sliding on down, number 7. So this one I'm going to use the shortcut. I'm going to use synthetic division. And since we're dividing by x plus 4, I'm going to use negative 4 as synthetic division. So in synthetic division, you just use coefficients. So 1, 12, 33, 1, negative 10. I got to be careful if there was a missing x term, I'm going to put a 0 in there. So slide the 1 down. Negative 4 times 1 is negative 4. Add them up. Negative 4 times 8 is negative 32. Add them up. Negative 4 times 1 is negative 4. Add them up. And negative 4 times negative 3 is 12. Add them up. So I have a remainder. This is my little remainder over here of 2. So since we started with x to the 4th, my answer is going to be 1 less than that. So it's going to start x to the 3rd. 8x represents the squareds. 1x minus 3. And then since my remainder is positive, I'm going to go plus 2 over this piece. X plus 4. All right. Moving on up to number 8. Which of the following is a factor of the expression? And what I could do is I could test synthetic division on these. So I'll do one that doesn't work and one that does work. Like I know A doesn't work. So I'm going to test negative 4. And this might be one where maybe you use a table. So maybe we go 4, 10, negative 6, and 20. And then I'm going to try things over here in this left-hand column. And this is where you can kind of do synthetic division, but you don't really have to write everything down. So I'll kind of show you what I mean by that. So basically you just put the answers after the addition. So I'm going to slide the 4 down. And 4 times negative 4, that's negative 16. Added to 10 is negative 6. Negative 4 times negative 6 is 24. Added to negative 6, that's 18. And negative 4 times 18 is negative 72, which will give me a remainder of negative 52. So that negative 4 does not work. So now I'm going to try positive 3. So we try positive 3. Slide down the 4, that's 12. Add them up. Times them, I get 66. Add them up. Times them, I get 180. Add them up. Not even close. So I try the next one, negative 2. Slide the 4 down. That'd be negative 8 added to 10. It's 2. Negative 4 added to negative 6. That's negative 10. And negative 2 times negative 10 is 20. And add it up. Oh, wait. Shoot. I did these wrong. This top one right here is supposed to be a negative 20. So that's going to change some things. I don't think it... I kind of know the answer to this one, so I know it doesn't change the top two, but let's just fill them in right. Negative 4 times 18 is 64. Negative 20, so that would be 44, so still doesn't work. 180 and a negative 20 is 160, still doesn't work. This one will come out to be 0, because negative 2 times negative 10 is 20. 20 add negative 20 is 0. When that happens, this is the winner. So the correct answer there is C. You also could have went to the graph and looked for zeros, and you would see a 0, or it crosses the x-axis at x equals negative 2. That was probably faster. Number 9, factor the expression completely. I always first try to pull out a greatest common factor. I don't see a greatest common factor, so I'm simply going to try to do it by grouping. So GCF the first part, which would be 5p squared, And reverse distribute, that'll be 2p minus 5. Then over in this other one, it looks like I can yank a 2 out. And that's also going to give me 2p minus 5, which is what I want. So I have a common term. Count it once. And then I have the leftover piece. Put that in a parentheses. And we have effectively factored the expression. So whenever there's 4 pieces, you can do it by grouping. So this one I can do by grouping, but I first want to yank out a GCF. And it looks like I could pull a 4 out of everybody. So I'm going to pull a 4 out of everybody, which will give me 2x to the third minus 10x squared plus 3x minus 15. All right, and then from there, I'm going to do some grouping here. So in the first part, I can yank out a 2x squared. Kind of put like a big old bracket around this. So yank out a 2x squared, and I will have x minus 5. And I think if I pull a 3 out, I will also have x minus 5. So inside of here, I will have a 2x squared plus 3. I have the x minus 5. And on the outside, don't lose your 4. And there we go. All right, number 11, factor completely. Well, this is the sum of cubes. So you have to kind of go back in your notes if you don't have this memorized and look at the chart. But the chart kind of says that if you want to factor a cubed plus b cubed, it's going to be a plus b, and then it's going to be a squared minus ab plus b squared. All right, so this is the sum of 2 cubes. So I kind of look and I say, well, both of these, if I take the cube root, like if I take the cube root of both of these, basically my a is 2x and my b is 5. A is 2x, b is 5. So just kind of filling out the pattern, if a is 2x and b is 5, so that's this piece. Well, now I have to do 2x squared, 2x times 2x. So that's 4x squared, minus a times b. Well, a times b would be 10x. And then plus b squared, that's a 25. And there we go. So we have factored that completely. All right, let's keep going. We're on a roll. Factor this one completely. Probably should have put a difference on here, but this one looks like the same thing again. So let's see here. I think I can yank a 4 out of that. So I'm going to yank a GCF out before I even get started. I'm going to pull a 4 out, and I get, what's that, 64 plus x cubed. And again, now I have the sum of the cubes. So sum of 2 cubes, it looks like this would be like 4 to the third plus x to the third. So a is 4, b is x. So let's kind of run that template that we had earlier. So don't forget your 4 on the outside. But then the first one was just a plus b. And then we had a squared minus a times b, so minus 4x, plus b squared, which was x. And there we go. And I don't think we can break that down any further, because I can't really think of 2 numbers that times together to make 16, add together to make -4. So I think we've got them broken down as far as they can go. Number 13, write the simplest function given the graph below. While writing the function, it looks like we have zeros right here at x equals -3, x equals 1, and x equals 2. So that gives me factors. That gives me factors of x plus 3, x minus 1, x minus 2. And I got to multiply this stuff out. So I'm going to times these two together. I just kind of like to distribute a 2 by a 3. So I'm kind of looking ahead. You can do it in any order you want, but this is x squared minus 3x plus 2 all times x plus 3. And now if you want to distribute, doing this x times everybody, I'll get x third minus 3x squared plus 2x. And then I'm going to get positive 3x squared, negative 9x, positive 6. Cleaning everything up, x to the third, they cancel, negative 7x, positive 6. So this is the simplest function that will give you those zeros. Now I could multiply it by 2 or by 3, and it'll have the same zeros. It'll just change the curve a little bit. All right, lastly, number 14, find all the roots. Or not lastly, I guess I got some more here. Find all the roots for the one below. Well, you could do the graph or you could do the PQ stuff. But I kind of see that since this is x forward x squared number, it kind of follows the same pattern as x squared x number. So you could just factor it like a quadratic type factor. So I'm going to put an x squared in both fronts. And then two numbers that times together to make 12, add to make negative 7. That'd be a negative 4 and a negative 3. Well, this one is the difference of squares. This one over here is not. So I'm going to have to deal with him a little bit differently. Well, it all equals 0. Well, this one equals 0 at negative 2. This one equals 0 at positive 2. This next one I got to actually solve. If I add 3 to both sides and then take the square root, I get positive or negative radical 3. So those are my other two roots. So I did have all 4 roots, 1, 2, 3, 4, all squared away. All right, number 15. So this one, I can't pull out a GCF. Doesn't look like I could group it. So I'm going to do the P over Q thing. I could graph it and try to find some. But P over Q, remember, this P is all the factors of positive 2. So that's plus or minus 1 and 2. Q is the number in front of here, which is just a 1. So really I only have 4 numbers to check. Positive 1, negative 1, positive 2, and negative 2. So let's try positive 1. I'll check him first. I'll run synthetic division, see if I get a 0. So slide it down. 1 times 1 is 1. Add them up. Negative 1. Add them up. Negative 2. Add them up. Sweet. I get a 0. So 1 worked. So I know x equals 1 is a factor. Now I know there's 2 more. And I'm going to be able to solve those 2 from this quadratic right here. And let's try to factor it. 2 numbers that times together to make negative 2 and add together to make negative 1. I think that would times to make negative 2 and add to make negative 1. So I think if I factor it like this, that'll give me 2 more zeros. X equals 2 and x equals negative 1. So I have 1, 2, 3 zeros. So these were all rational. These give me all my rational roots. That's kind of nice when that happens. Next one. Well, first thing I notice is I see that pattern again where it's x4, x2 number. So I try to play the game with 24. And I say, well, can I do, it looks like maybe a negative 6 and a positive 4. I think that would work out. So I'm going to have x squared minus 6. Now you could have did the PQ game. You just got to make sure you put zeros in for x to the third and x to the first when you do synthetic division. But I'm going to kind of go a different route. And neither of those are the difference of squares. So I just got to solve them. So when are u 0? Well, you're 0 when x equals plus or minus negative or radical 6. So that gives me 2 roots right there. Then I got to do this side. Oh, when is x squared plus 4 equals 0? Here's where I run into an issue, because I get x squared equals a negative, and when I take the square root, it's going to give me imaginaries. It's going to give me a positive or a negative 2i. So here is my other 2 roots. So I have 2 complex roots, imaginary numbers, and then I have 2 irrational roots. And this one I didn't have any rationals. So P over Q would have kind of screwed me over, because I would have tried to do all the things that go into 24, and none of them would have worked. So that would have kind of sucked. The graph probably wouldn't have been much help too. So I think this was about your only route. All right, hopefully this helps you up on part 1 of the review. We will do part 2 tomorrow. See you.